Let us take examination question paper problem, VTU Exam paper problem, January 2021. If the resultant of the two forces shown in the figure is 700 Newton, directed vertically upwards, find the angles alpha and beta. So it looks like a simple problem. See, it is a concurrent force system because these two forces lines of action are meeting at this common point O. So he has given the magnitudes of these two forces. Angles are not known, alpha and beta. So there are two unknowns here, alpha and beta. They are the unknowns. To find these unknowns, we need two equations. So for deriving those two equations, he has given that the resultant force of these two is 700 Newton. That means it is acting vertically upwards, means resultant is acting like this along y direction. This is y direction, this is the x direction. Resultant is acting along y direction. So this value of the resultant also is given 700 Newton. That means when the resultant is acting along y direction, so the condition is your sigma Fy itself is equal to resultant. This is the first condition. So here resultant has given 700 Newton. So what we have to do here is we have to resolve these two forces and find out the components of these two forces along the y direction and add them algebraically. So when you are using this equation, I will take upward forces positive, downward forces negative. So this 400 Newton force, if you resolve, so it will come like this and like this. This 500 Newton force, if you resolve, it will be like this. So that means, since this beta is given with respect to vertical, this becomes 400 cos beta and this becomes 400 sin beta. Whereas here, this becomes 500 cos alpha, this is 500 sin alpha. So 500 cos alpha and 400 cos beta, they are the vertical components. 500 sin alpha and 400 sin beta, they are the horizontal components. Now, if I take the sign convention, so both these two, they are positive. So therefore, I can write 500 cos alpha plus 400 cos beta is equal to 700. So this is the first equation. Now you can simplify this. This becomes 5 cos alpha dividing throughout by 100 plus 4 cos beta is equal to 7. So this is the first equation. You cannot solve this because there are two unknowns alpha and beta. Now the second equation is sigma fx will be 0. Please note that since the resultant acts along y direction, algebraic sum of the forces along x direction, that is the x component of the resultant, will be 0. So therefore, for writing this equation, I use the sign convention. Forces acting towards right positive, left negative. If you use that, 500 sin alpha minus 400 sin beta is equal to 0. This is the equation. Or you can write this as 5 sin alpha is equal to 4 sin beta dividing by 100. So this is the equation you are going to get. This is equation 2. Now both are the trigonometric equations. If you solve this equation 1 and 2, you can get the values of alpha and beta. So whenever you are having trigonometric equations in sin and cos, it is always better to convert to one ratio, either sin ratio or cos ratio. By using the relation, you know this relation, cos square alpha plus sin square alpha is equal to 1. So this relationship you know. Using this relationship, we can solve the equations. Now what we can do here is, so let me take this second equation. So from equation 2, if you square that, 25 sin square alpha is equal to 16 sin square beta. Because I need this square term, so I have squared it. Or I can write sin square alpha is equal to 16 divided by 25 sin square beta. This is what I can put for sin square alpha. Now I will take the second equation. So this I will call it as 3, relation to 3. Consider this equation 1 now. From equation 1, 5 cos alpha is equal to 7 minus 4 cos beta. Now I will square both sides. Squaring both sides, 25 cos square alpha is equal to, this is a minus b whole square, a square plus b square minus 2ab, 7 square is 49, plus 4 cos beta square is 16 cos square beta, minus 2ab means minus 56, 7 into 4, 28, into 2, 56 cos beta. This is what you are doing. Now what I will do here is, for this cos square alpha, I will substitute 1 minus sin square alpha. So put cos square alpha is equal to 1 minus sin square alpha using this relation. So it becomes now, therefore, this equation now becomes 25 into 1 minus sin square alpha. 25 into 1 minus sin square alpha is equal to 14 plus 16 cos square beta minus 56 cos beta. That means I am trying to eliminate this sign term. Now 1 minus sin square is alpha is variable here in the LHS. So 25 into 1 minus, you have this relationship. For sin square alpha, you can put 16 by 25 sin square beta. 16 by 25 sin square beta. So 1 minus of this I can write is equal to 49 plus 16 RHS remains 16 cos square beta minus 56 cos beta. Now once again for the sin square beta, I will put it as 1 minus cos square beta. So let's if you substitute for sin square beta as 1 minus cos square beta, 25 into 1 minus 16 by 25 into sin square beta is 1 minus cos square beta. So you should do carefully, is equal to RHS remains the same, 49 plus 16 cos square beta minus 56 cos beta. So now you can see that this equation can be reduced to a quadratic equation in cos beta. So let me simplify this now. 25 minus 16 by 25. So 16 by 25, I think it is 0.64. So what I can do here is I am going to multiply. 0.64 is there. That okay. Otherwise I write 25 into 1 minus 0.64 plus 16 cos square beta. Just I have multiplied, I have removed the brackets, is equal to 49 plus 16 cos square beta minus 56 cos beta. Now this becomes 1 minus 0.64 is 0.36. Now let us simplify that. So 0.36 into 25, 0.36 into 25, which is equal to 9. So 9 plus 25 into 16. Oh, sorry, this is 16 divided by 25. Yeah. Be careful here, that's what. This into this 16 by 2. That means it becomes 16 cos square beta. So this into this is 9. 16 by 25 gets cancelled. 16 cos square beta is left, is equal to 49 plus 16 cos square beta minus 56 cos beta. Now you can see here the 16 cos square beta term will get cancelled. So you will be left with now 49, this 9 I will bring to that side, this I will bring to this side. 56 cos beta is equal to 49 minus 9 is 40. So our cos beta is equal to 40 divided by 56. So 40 divided by 56, the value is 0.714. 0.714, or I can write beta as cos inverse of 0.714 which is cos inverse of 0.714 is 44.4 degrees. Beta is 44.4 degrees. Just a solution of trigonometric equation containing both sin and cos term. You have to convert to any one of the ratio, either sin or cos. What equation you are going to get? Next, once you get the value of beta, you can find out the value of alpha by using any one of the equations. That is either equation 1 or equation 2. Now let me take equation 2, substituting for beta in equation 2. You can get the value of alpha now. So 5 sin alpha is equal to 4 sin beta is 44.4 degrees. Therefore, sin alpha is equal to 4 divided by 5 is 0.8 into sin 44.4 degree. So sin 44.4 degree is equal to 0.699, then we can take it as 0.7. So that means it is 0.56. 0.7 into 0.8 is 5.56. Therefore, alpha is sin inverse of 0.56. So sin inverse of 0.56, which is 34.06 degrees. 34.06 degrees. This is the answer alpha. So like this, you can find out the two unknown angles by using the two equations of the resultant. One is sigma fx is equal to 0. This is because the resultant is acting along y direction. Another one is sigma f is equal to itself is equal to resultant because the resultant is acting in y direction. There is no component in the x direction. So using these two conditions, we can find the unknown angles alpha and beta.